application leader with GE Ultrasound, and I'm so pleased to share with you this morning one of our engineers, and Yelena's going to walk me through how we perform strain elastography on the logiq E9.
Hello, I'm Yelena Tsambalenko. I'm a software architect, and I will be helping Mary in her demonstration of strain elastography.
So what I'm using is our ML6 to 15, and I'm actually going to change it to the small parts breast preset. And what we're going to do is optimize our 2D image. And once we get a good 2D image, elastography is a really nice additional tool to add to our evaluation of the lesion. So once I'm done taking all of my 2D images and measurements of the lesion, I'm going to want to give some information about the stiffness of the lesion now. So in order to do that, I'm going to press the elasto button on the operator panel. When I press that button, what you'll see is a side-by-side image on the monitor. And we really like this display format. And one of the things that I'll tell customers to do is when they're actually performing the elastography is to keep their eye on the image on the left-hand side. The image on the right has our region of interest. This is where the elastogram is going to be generated. Now the size of the region of interest, this would be too small because the system is only going to give you elastography information from within the lesion. What the goal is and how the algorithm works is we want the region of interest to be large enough so that we can compare the lesion stiffness to the surrounding tissue. So notice I've got the lesion centered within the region of interest, and I have a sufficient amount of information on either side of the mass. The technique is very important. We're going to be pushing down on the transducer, and our goal is to stay on the skin and then push straight down in a perpendicular fashion. We don't want to rock the probe while we're pushing or in any way. It's literally straight up and down motions. Now, one of the things that you can use as a guide is once you have given the system 3 good repetitive compressions, you're rewarded with a full green quality bar. So if you look at the monitor, I'm just going to freeze here for a second, and I'm going to roll the trackball back. I'm going to take a frame or gather a frame where I have my quality indicator in the center here is fully green. So again, as long as I give the system 3 repetitive cycles, I'm rewarded with a full green quality bar. And that's how I know that I've given the system sufficient information. Next, we can then look at the elastogram and say, how is this lesion in comparison to the surrounding tissue? And what we can see here is that there's a fully blue pattern. Blue is represented with something that is hard or stiff. We can actually invert these colors and make red hard and blue soft, but the way that it's set up right now, blue, fully blue, is considered hard or stiff in comparison to the surrounding tissue. Additionally, and I'll go live again and just do another demonstration for you, when we do those good compressions, another way that your clinicians that you're working with will be able to evaluate your technique is if you're really pushing straight down perpendicular on that lesion, you'll also see a good amount of symmetry across your elastogram. So again, if we just look on the right side of the image, notice that it's blue all the way across the top, hard or stiff in the center, and then I have a very similar pattern of red from side to side. And so this is how the clinicians know that you weren't healing and towing and that you were pressing in a perpendicular fashion with the transducer.